Now have a look at the combustion chamber case where the borescope ports are located. 4 borescope ports are provided around the combustor case. 2 borescope ports are provided around the HP turbine case. These ports are used to inspect the HP turbine blades. Note that the igniter ports can be used for inspection of the HP turbine nozzle assembly. For borescope inspections of the LP turbine, 4 accesses are provided on the LP turbine case. For inspection of the first stage, use the same port as for the HP turbine. As for the 3 other stages, use the ports along the LP turbine case bottom line. On the right-hand side of the engine core, we can also identify other components which are part of the active clearance control system. We have the LP TACC valve and the HP TACC valve. The LP-TACC valve, which uses fan air taken in by a scoop in the C duct for external case cooling of the LP turbine. And the HP-TACC valve, which uses 4th and 9th stage air for internal cooling or heating of the HP turbine shroud structure. This valve is fitted with a visual open-closed position indicator. The rotor active clearance control valve will be dealt with later with the presentation of the other side. 2 T-case thermocouple sensors are installed on the engine, one on each side for the HP TACC valve control. When looking at the turbine rear frame, we can see the oil supply and scavenge lines for the aft sump. And a drain line to evacuate any water or fuel accumulated in the LP turbine case. Let's continue our tour around the engine. When walking up to the rear, we can see the center vent tube and inside the flame arrestor. Now we are on the left-hand side of the engine core. We can locate the rotor active clearance control and start bleed valve, RACSB. This valve uses 5th stage air to control the HP rotor cavity thermal expansion and 9th stage air to unload the HP compressor during the engine start acceleration. At the top of the engine, 2 attachment mounts are provided for attaching the engine to the wing. The forward mount and the aft mount. For the exhaust gas temperature, EGT, measuring plane. 9 thermocouples are installed around the LP turbine case, corresponding to aerodynamic station 49.5. The thermocouple's alumochromal material wirings are connected together to parallel junction boxes. And then to a main junction box. Here is the second TK sensor used for HPTACC valve control. At Aerodynamic Station 3, HP compressor discharge, two sensors are provided for temperature and pressure sensing. One is the T3 sensor, located at the 11 o'clock position. And one is the PS3 sensor, located at the 9 o'clock position. On the pneumatic system, two customer bleeds are provided from the 5th stage for intermediate pressure and from the 9th stage for high pressure deliveries. A check valve is installed on the IP duct. An HP bleed valve is installed on the HP duct. And a bleed pressure regulating valve is installed downstream on the common duct. The bleed pressure regulating valve and the HP bleed valve are fitted with a closed-open visual indicator and manual override. For fire detection purposes, there are two fire sensing elements installed on the engine core. Two more are located on the pylon zone and two others on the accessory gearbox. Here is the sensing element of the engine core left side. Each element is connected to its related fire detector responder housing. Note that in the hot section, the head is of the ceramic type. Remember, on the right-hand side, we saw part of the variable stator vane system. The actuation of VSV is performed by two actuator and bell crank assemblies. One is located on the engine core right-hand side, and the second is located on the engine core left-hand side. Each VSV actuator has a LVDT sensor connected to the ECU for position feedback. The left actuator LVDT is connected to channel B and the right to channel A. Notice that no rigging procedure is required on this system. The other system installed on the engine for compressor airflow control is the VBV, Variable Bleed Valve System. It consists of 12 VBVs. The system is actuated by means of a fuel gear motor which drives a master ball screw actuator and bleed valve assembly via a stop mechanism. The other 11 bleed valves are driven by means of a flexible shaft. The VBV positions are taken from the master bleed valve feedback rod linked to an arm lever fitted on a rotary variable differential transducer, RVDT, which sends the position feedback signals to ECU channels A and B. For the rigging procedure, make certain that, when the valves are fully closed, the mark on the RVDT is aligned with the mark on the arm lever. Note that the variable bleed valves are closed when the engine is shut down. They will be open during engine start. Before leaving the engine core section, have a look at the bundle junction box, where pipes, ducts, and electrical wirings are routed. Now, let's continue the presentation with the components located on the left-hand fan case zone. First of all, the fuel system components. When following the fuel feed manifold from the aircraft tanks, we arrive at the fuel pump assembly installed on the accessory gearbox. The fuel pump assembly consists of two pumps, LP and HP stages, and a fuel filter. The fuel filter, which is a disposable cartridge type, has a drain plug for drainage and sampling. For monitoring to detect if the fuel filter is clogged, a fuel filter differential pressure switch is installed at the 9:30 o'clock position of the fan case. On the accessory gearbox, the hydromechanical fuel unit, HMU, is fitted with the fuel pump assembly. The HMU has several torque motors and solenoids integrated on it, which are not line replaceable. If a torque motor or solenoid fails, all the HMU must be changed. The fuel is heated before entering the HP fuel pump and HMU. The fuel is also used to cool engine oil through the main oil-fuel heat exchanger and servo fuel heater. Part of the fuel is used as servo pressure by the HMU for the actuation of subsystems, that is to say, VBVs, VSVs, ACCs, etc. The fuel metered from the HMU then passes through a fuel flow meter. Then the fuel is directed to the combustion chamber. Part of the fuel is used for IDG oil cooling purposes. For IDG oil cooling purposes, the IDG oil cooler and the fuel return valve are located on the fan case upper part. The IDG oil cooler always ensures the IDG oil cooling by means of bypass fuel from the HMU. The fuel return valve ensures a fuel recirculation to the aircraft tanks for additional IDG oil cooling under certain aircraft fuel system conditions. And the ECU control depending on the engine oil temperature. An ECU, engine oil temperature sensor, is installed for that reason on the engine oil supply line going to the forward sump bearings.